Hi everyone, I hope your spring break was restful, and I hope you got a lot of stuff done even though you couldn't go out. But we're going to continue with piecewise functions now, and we're going to look at a different kind of piecewise function. On the left on your starter, you could see the traditional kind that we've been looking at. But starting yesterday with your starter question that was on the Google form, you saw this table right here, and I asked you to complete it. So now we're going to see how we actually should complete this table. Hopefully you notice the pattern from the left side of the table. You notice that negative 17.1, oh, that became negative 18, negative 9.68 became negative 10, etc., etc. And really, this area here should provide the most clue as to what this floor function does. So hopefully you notice that what a floor function does, and hopefully you notice from the name as well, like thinking of the floor, a floor function takes your x value, your input, and makes it into the bottommost integer that is closest to the function. So what I mean by that is negative 2 is an integer, and therefore the closest integer that's below it is negative 2. Negative 1.3, not an integer. The next integer that's closest to it, but is below it, is negative 2. Because like if we look at a number line, all right, let's say 0 is here, negative 1, negative 2. So negative 1.3 is like right here. The next closest integer below it is negative 2. Similar with negative 1.1. Negative 1.1 is like right here. And the next closest integer below it is negative 2. So it is that's why it's called a floor function, because it's the closest integer below, just like the floor is below you. So let's look at these. And if you want to use a number line, you totally can. Let me draw another number line over here that's nice and fresh. So if we have 0, 1, 2, 0.1 should be like right here. We want the floor, so the next closest integer below, that's going to be 0. You can see that if we have to go left to the floor of it, the next integer is 0. 0.2, the next integer to the left is also 0. Same for 0.3, 0.5, 0.8, 0.99. The next closest integer, these numbers are all here. The next integer to the left of it, or below it, is 0. And then we reach 1. Now 1 is an integer, so the closest integer to 1 is going to be 1. Now let's look at 1.5. Let's do 1.5 in a different color. 1.5 here. We want to look below 1.5. The closest integer below is going to be 1. And same thing with 1.8. 1.8 is like over here. The next closest integer below it is still 1. So that's how floor functions work. You need to look for the closest integer that is below the number you are given. And that's what we can write for part A. How do we complete the table? We looked for closest integer below the given, below or less than. Below the given number. All right, so let's create a graph of what this floor function looks like. So we just want this from negative 2 to positive 2. So negative 2, the closest integer to negative 2 is negative 2. So if you're given x is negative 2, we're going to go to y is negative 2. Any of these decimals in between negative 2 and negative 1, this closest integer is going to be negative 2. So we're going to have a nice little line here because all of these decimals, they're going to go to negative 2. But then where the switch is at negative 1. Negative 1's closest integer is negative 1. And now since this is a function, negative 1 is not going to go to negative 2. We need to show that this line ends, and it's going to end with a hole. Now let me erase these so we can have a nice clean graph. All right, so now all of these decimals between negative 1 and 0, all of them, their floor is going to be negative 1. So we're going to have a nice line here, and we're going to have something very similar to what we just saw with the negative 2's. The closest integer 0 is 0, so this filled in dot will be here. It's not going to be down here, so we're going to have an empty dot over there. And then, of course, it's going to be similar again. We're going to have a nice line and an empty circle because the closest integer to 1 is 1. So 1 is the floor of 1. And then we're going to have this and another empty circle. So this is what a floor function looks like. Now, as you can see, this is a piecewise function because this function is in pieces. So we can write it with our piecewise notation. So if we want y equals the floor of x, so if y equals the floor, and this is the notation for floor, it's like a bracket but with just the bottom little feet here, no top feet. So this, as a piecewise function, we have 4 parts. So we're going to need to do each one of those. So let's look at this pink section first. That's going to be, let's see, our y value is negative 2. And this happens on what domain? Well, this happens between negative 2 and 1. So negative 2 is less than, the filled in circles there, so we need an equal sign. Less than or equal to x, and only less than 1 since we have an open circle over here on the other end. All right, next part, let's look at this green part. Let's see, that y value is negative 1, and that happens from negative 1 to 0. And note, we have the equal sign with negative 1 because we have the filled in circle. But we have the open circle at 0, so we don't have an equal sign with 0. And then we have 2 more parts, but they're going to be very similar. So we'll have y is equal to 0, and that happens from 0 to 1, and then y equals 1. That happens from 1 to 2. So officially, what a floor function is. A floor function is the greatest integer that is less than or equal to our x value. And this is denoted like this, like the way it was in your table. Floor of x is written like that. So that is a floor function. All right, so let's now look at a different kind of function. Notice this doesn't say floor anymore. Now this says ceiling. So ceiling is going to work very similarly, except instead of looking at the next closest integer below, we want to look at the ceiling, and the ceiling is above us. So we can see, okay, negative 17, the next closest integer that is above negative 17, if we make our little number line, 16, negative 17, negative 18, negative 17.1 is like right here. If we look above or to the right, negative 17 is the closest integer above. Negative 9.6, if we have another number line with negative 8, negative 9, negative 10, negative 9.68 is like right over here. Closest integer above it is negative 9. So we can see that here. And the same will follow for the rest of these numbers. So 0.1, closest integer above it, 1. 0.2, same thing. These are all going to be 1. and 1 is an integer, so of course this closest integer is 1. 1.5 is right over here, so the closest integer above it is 2. 1.8, very similar, closest integer above it is 2. So there are the answers to your starter from yesterday. And that is how a ceiling function works. We looked for the closest integer above or greater than. Greater than the given x. So let's create a graph now. Same domain, -2 to 2. -2, of course, will go to -2 because it is an integer. You know what? Let's fill in all our integers first. -1 will go to -1, 0 will go to 0, 1 will go to 1, and 2 will go to 2, though we don't need to include 2, so no need for that. Let's get rid of that. All right, well, let's see now. All of the decimals between -2 and 2. What is the closest integer that is above all these decimals? Well, we have some up in our table. For example, these right here these are integers between -1 and -2, and they became -1. So all of these, this green area here, those are all going to have a ceiling of -1. And we'll have an open circle here because -2 was an integer, and we already know that had a dot in -2. Now for the next section, oops, all of these, 0.5, 0.2, they have a ceiling of 0. So they're going to have a line right here with a dot over here. And then the other section will be very similar between, let's get another color. Let's get blue going on here. So in this area, 0.5, 0.8, 0.9, their ceiling is going to be +1 because that's the next integer above it, except for right there, except at 0 because 0 is an integer. And then the next set will have this area right here, and I guess we'll put that dot back in just to show that it ends. So this is a ceiling function. And again, it is a piecewise function, so we can write it in piecewise notation. So y equals the ceiling of x, again, 4 pieces. So that first piece, we could see the y value here is -1, and that happens from -2 to -1, but we need an equal sign with the -1. The pink section here, we could see that y value is 0. That happens from -1 to 0, and we need that equal sign at 0. Then we've got the blue section here, that y value is 1. That happens from 0 to -1, and that last section, I'll just write in black, that y value is 2, and it happens from -1 to, oops, what's happening with notation? Happens from -1 to 2, but look, oh, we are including 2. I was thinking we weren't, and I forgot my equal sign up above as well. There we go. All right, so there is our ceiling function. So what a ceiling function officially is, it is the least integer that is greater than or equal to x. Denoted as ceiling of x, which has the little feet at the top. like a ceiling.